Hello. So in this video, we're going to be talking about filling in some of these trig values for some reference angles. These are the most common angles that you're asked to know off the top of your head without using a calculator. I have written the degrees and then the radian equivalent. You should be able to toggle between both. So without further ado, let's kind of get started here. So to fill these in, for the pi over 6, pi over 4, and pi over 3, these rows can come from your special right triangles. So the sine of pi over 6, I would have to come over here, look at this pi over 6, and sine is opposite over hypotenuse, so 1/2, okay? Following that same strategy, I can do the sine of pi over 4, which is rad 2 over 2. And last but not least, for 60, or pi over 3, I would do opposite over hypotenuse, so rad 3 over 2. Now, for sine of 0, we could do it a couple of different ways. You can look at the unit circle, and here's 0 degrees. This is the point 1, 0. X is cosine, y is sine, y is sine. So my sine in this case would be 0. I could go back the other way as well, filling these guys in. So the cosine of 0 would then be 1. And then following all of my little tricks, using my special right triangles, I could fill the rest of these in. I do want to bring your attention to a trick that you can use if you set up this table. So if you just start like with this table completely blank, notice the numerators 0, 1, 2, 3. And then everything has been square rooted. The square root of 0 is 0, square root of 1 is 1, rad 2, rad 3. And then notice they really are all divided by 2 at the very end, but 0 divided by 2 is just 0. For this guy, it goes the kind of the opposite. I probably should have added 90 here too, but like pretty much just follow, oopsies. If you follow the pattern here, now it kind of goes backwards. 3, 2, 1, see, square root, square root, square root, square root of 1 is 1, and then I divided everything by 2. Cosine of 0 is 1. And you can get that from the unit circle, and we can also get that from the graph of trig functions, which we're going to talk about in a second. Now, to get tangent, we know tangent is sine over cosine. So all I'm doing is I'm dividing these little guys. 0 divided by 1 is 0. 1/2 divided by rad 3 over 2 is 1 over rad 3. If you wanted to rationalize that, you could write it as rad 3 over 3. It doesn't matter. For this next one, sine divided by cosine, I'm going to get 1, and then rad 3 over 2 divided by 1/2 is just rad 3. So again, these are things that you're going to want to commit to memory. So when I see any questions that involve like trig, I will almost always regurgitate this little table. And the other thing that I would draw are my sine curve and my cosine curve. And I actually think I have a nice drawing of these here. So why these are important, okay, is because now you have all of your values as far as if I said, hey, what is the sine of 0? You could just look right at the graph and say 0. Or what is the cosine of pi? Well, you can come right here and then see that it is -1. Sine of pi over 2. You can hop right on over here and identify that as 1. So the graphs are good for those like angles that are 0, pi, 2 pi, or 0, 90, 360, 270, and 180. Oops, I should probably 180 goes with that, right? So anything that is on this increment of counting by halves, you would look at the graphs, okay? And that's it.